Okay, thanks, Liam. Yeah, again, thanks to Liam and Kathy and all the organizers for their patience as I was trying to get a passport in time to go. So fortunately made it here. Forgot my deodorant and my pants are a little tighter than they were 2 years ago, but I managed to fit into them. So happy to be here. Excellent lunch. So hopefully I won't put you to sleep after that lunch. But I'm going to talk a little bit about what we're doing up in Canada. My name is Matt Arkett. I'm in the Meteorological Service of Canada, which is part of the Department of the Environment. My role there is a lot of SEO, satellite Earth observation, but my main role is the manager of both the geostationary and the polar orbiting networks that we manage and use to provide data to our users and forecasters. So I'll talk about GEO. We finished a project in 2019 that I'll talk about, and then the LEO is the basis of work for us for the next number of years to replace the current polar orbiting network. I also, if you'll indulge me, I'd like to just make a couple of slides on what we're doing on satellite Earth observation in Canada writ large, especially across the government. There's been I would argue, a large focus over the last few years, and I'll talk a little bit about some of the exciting things that are happening within Earth observation in Canada. So this is an old slide from my old manager, David Bradley, who I think some of you guys know in the room. So I inherited the networks from Dave. And at the time, the GOESR, what we'll call the GOESR Readiness Project, was just starting. But in the past, we've been using direct broadcast since 1995. Much more regionally. So in the old days, we had we called them storm prediction centers, SPCs. I think we had 11 across the country, and due to program review, they, like everything, they condensed that down to less offices, and as a result, in the old days, we had regional antennas at each office, and they were generating their own products for their specific regions using. At that time, it was the GVAR software, info electronic software that we were using, and everybody had their specialty products that they were using for their specific regions. GOESR Readiness, or GOESR, was that opportunity to revamp the network and also consolidate it into something a little bit more manageable. So as you can imagine, U.S. is a big country, Canada is a big country too. So trying to maintain those antennas was difficult. You had a lot of different systems. So the GOESR project was an opportunity to really, make that a little bit more efficient and also more resilient. So very boring slide, but we did set up a project, and it was 5 years, a project where we had 4 components, plus we did GLM validation, and we did what I call here component 5, which is a CCMEP. That's our Canada Centre for Meteorological Environmental Prediction. So they are doing some nowcasting stuff with the GOES product, but the main core of the project is the 4 pieces there. So user needs, that was the first thing we needed to understand, was of all the GOESR products, what were the most important, what did the users want to see? And of course, it was the cloud and moisture imagery was number 1, and then we had a listing of all the rest of the products that were coming out, especially level 2s that were of interest to our users. Component 2, the reception and processing. So the reception was really in my shop, and in my group was responsible for the upgrades of the antennas, which I'll talk about in a few minutes. Component 3 is we use NINO as our forecast workstation. So different with what the difference between moving to GOESR was a complete change of products, data, frequency of data. So there was just a massive change. So we had to make sure that the forecast workstation was going to be ready to receive the data. And I'll talk a little bit about that because that is something that's a bit of a bottleneck for us on the satellite production side. And then finally, user readiness. And I'll talk a little bit about the training and getting our staff ready for GOESR. So as I mentioned, we had 11 antennas across the country. We made a decision to bring that down to 4, having 2 for GOES East and 2 for GOES West. We have the 2 what I'll call our primary antennas at Dorval. So Dorval's in Montreal. For some of you who've been there before, maybe the 8 at the TOBS meeting was there. So that's our what we call our Canadian Meteorological Centre. So you can see from the picture in the top right, bunch of antennas on the roof. We retrofitted those with new feeds and demodulators, etc., for both GOES East and GOES West reception. also kept one of the GOES 15 antennas, so we have been, as we went through that GOES 17 transition, where GOES 15 we were continuing, and we still have capacity to process GOES 15 data, and have been doing that through each of the solstice periods to maintain the GOES West imagery. The other two antennas are what we call our secondary antennas, or our backups, one in Downsview, which is in Toronto, and the other one in Vancouver, so for GOES West in Vancouver. Boring slide maybe a little bit, but it also gave us an opportunity to kind of condense and to make our data processing architecture a little bit more centralized, if you want to say. So obviously we have not experimented with decoupling acquisition from processing. We keep the acquisition and the processing machines on site. So the data we receive at all 4 antennas. It's all processed down to level 1B. But there's the operational feed, which then goes into all the product generation that we create for our users. And then we have a centralized dissemination service, which essentially spits out all that data, all the users. CSPP Geo is running on acquisition and on the processing machines. So I'll talk a little bit about that in a minute. Products. So we are constrained by NINO, and you may wonder why some of these products look a little bit weird. Obviously, the ones in the top left and right are fairly, we've cut the full disk into segments that cover Canada. We've got a good overlap between the east and the west, but we're very limited by how much data we can send to our users to the NINO system. The NINO is what our storm prediction centers use. We have other users, but they're the primary users. So as you can see from the image on the bottom, we've had to cut our CONUS files into very thin and smaller files so that we can deliver that data to our forecasters in the right amount of latency. So it's a little bit, we do deliver all 16 channels in black and white. We don't send any RGBs, pre-canned RGBs. That is a plan for the future, but right now the forecaster has the ability to generate those RGBs at the desk using the input data. We don't have mesoscale in NINO, but we have used mesoscale before, and I can't remember, I think it was Andy who asked the question about to the last presenter. We did actually order mesoscale. We always keep an eye on it. Most importantly, because the northeast segment is just below Montreal, so it's really useful for those folks. I think we've even made a request if there's a chance to nudge that up a little bit. But we have asked for it. We had a severe convection event in Alberta, and we have a protocol that we used, and we worked with NOAA to get that data, and we had it delivered. And then our forecasters were using it through a WMS, but we were successful, and we continue to put in orders when we feel the need for it. Yeah. So this is the NINO workstation. Maybe some of you may be familiar with it, but this is the workhorse for us. And yeah, as I mentioned, our big challenge is the data to this. And as I mentioned, one of the big challenges is the amount of data that's coming to users right now. And there's a large push in the Meteorological Service, and the same with, I'm sure, the other agencies to use modeling data, and there's a lot of it. So we compete a little bit with the model data, and we have a certain amount of bandwidth that we're allowed to fill, and that's what we do. But we're getting more and more requests for more satellite data, which I think is important. There are other clients, so I talk about our forecasters in the offices, but we also create a bunch of other products for different users. National IM are just it's a legacy piece of software that forecasters have been using for many, many years and will not give up. So we've had to create special IM, they're called IMv6 files for them in certain regions and certain sectors. Our aviation and defense, so the Meteorological Service of Canada, also supports our Canadian military. So they have a demand for a lot more than just GOESR data. They've actually just asked us to look at Himawari data as well, and if we can get that to them. And they're also getting Meteosat, so they're looking at the full globe. So we're working right now to look at how we can access Himawari data from the PDA. Our weather office website, so I think it's at, I don't even know the millions of hits it gets a day, but we do push products to that as well. Always fun to, when you get an inquiry about a certain data file, we get a lot of questions about satellite artifacts or things they see in imagery, but it's a big access point for the public. So a lot of public users go to our website and pull our data. We're trying to move away from the static image and start to do WMS, so web mapping services. So as part of our development moving forward, as I mentioned, the NINO environment is difficult to serve a lot of data to, so we're actually looking at web mapping services as a way to feed additional products. So those products I showed you that were going to NINO, we're not producing the L2s yet. We do pull them from the NOAA PDA, and they do go into our nowcasting system. But the forecasters have asked for them to be put into NINO, but unfortunately we just don't have the space to put it in there. It causes too much performance issues if we overload the data. So our plan to moving forward is to use web mapping services. So that's going to be part of our weather office, but also going to be where our users can also get access to the data. One of the other things we do is we support the Haiti weather office. We provide products to them as well. So that's one of our data feeds, so we spit those products out to Haiti. The Canadian Ice Service, they're a big user of the data also. Rumors are they have a large TV screen in their main operations office, and they run the GOESR data to see sea ice motion. So they get the 5-minute data, and they run that on operations floor to keep an constant ongoing look at how the sea ice is moving in around Canada. Research and development, it's a big part, the nowcasting system especially, where we're using the level 2s to validate model outputs and then combining those into products for our forecasters. So another really important user base. And then finally, environmental emergencies. So that is another one. So using that data for models, also to predict where things are happening. Would be remiss to not mention the amount of training that went into when we did GOESR. Had tremendous support from the community, especially NOAA, SIMS, and the CSPP folks too, where we've had, we had a train the trainer. We've developed our own modules internally on GOES data for training. But I would argue the CMOS trainings that we did with Scott and a bunch of other folks touched a lot of those forecasters we had in the actual, what we call our satellite focal points into those training, and then they took back that information to the SPCs and fed that back to the users. So really good sessions. We did it 3 years in a row where folks came up and gave these sessions and very well received. So this is just an overview slide to show the end-to-end system, how we have it set up. There's a lot of resilience in here. So we have, like I mentioned, the 2 antennas for each, a primary and a secondary. So right now the primaries are Dorval, but we have that ability when there's problems to switch, which is really important. Next thing is the PDA. So we do use the PDA as what I'll call our 3rd level backup, and we actually just used it in the interleave test. So our satellite production system, SAT-PS, which is the CSPP based software, needs to be updated for the satellite IDs, and so we thought we were going to have a 4-hour outage, and we decided we'd try the PDA for access to that data during that 4-hour outage, and we were able to deliver products to our forecasters. Obviously some latency issues with channel 2, so they were coming in a little bit later, but for the rest of the channels they were being turned around pretty quick. I think it was an average of 7 minutes or something like that from NOAA PDA to the screen, which wasn't bad, and it kept the forecasters with some data rather than no data during that 4-hour period. We're working now to upgrade the software to make sure that when the next test, which I think is August 1st, that we were able to run it through no problem. And then we don't archive any data in Canada. Didn't feel there was any need given the class archive. So anybody that wants archive data just goes to class to get it. And then again, there's just the users on the side. Again, all driven by CSPP. That was a big big coup, I'd say, for us to move away from supporting the commercial software. We were able to develop in-house with the support of Graham and the rest of the CSPP team to customize it for what we need, and the plan is to do the same when we move on to our LEO project. So I'll move on to that. As I mentioned, there's the GEO network, but we also have a polar orbiting network. It consists of 4 stations. They're here on the screen. 2 in Alberta, Edmonton and Stony Plain. They're both almost right beside each other. 1 in Gander, which is on the east coast of Canada, and then Resolute, which is in the central Arctic. So Resolute and Stony Plain are only L-band reception, while Edmonton and Gander have X and L. Sea-Space antennas from 2007, I think they originally put in. They've been moved around to a few places, but this is the current configuration. And that's how our users are getting the polar orbiting data. Polar orbiting data is very important for Canada. I mean, it's important for everyone, but we have a large Arctic region, and it's no surprise to this room. As you go further north with GOES, it does suffer from a resolution problem. So the polar orbiting data is quite important, and especially for aviation in the Arctic, as well as the communities that we serve. As I mentioned, so these are the L and the X-band satellites that we're currently receiving. You'll see we're missing some. We're not getting NOAA 20. So a lot of those L bands are starting to slowly disappear. I just took MEDOP-A off this slide the other day, getting prepared for this talk. And we are contributing to DBNet, to EARS, and to NOAA from our Gander and Edmonton stations. Small amount of data, but we are contributing stations. Unfortunately, we're having some issues right now that Nick has been supporting us with, but this is the reason for my next slides. Essentially, our MSC network, our polar network, is rusting out, has been rusting out for a number of years. So we put together a budget proposal to our cabinet. We went forward in budget 2021, asking for money to replace the network, and we were successful in receiving that money, and it just started flowing into our coffers this past fall. What are we trying to do with POS renewal? What I'll call POS renewal. I know that's a bit of a catch-all phrase, and Europeans probably don't appreciate it being called POS. We call it GOES and POS networks. It's just easy. But what we want to do is expand that coverage. So currently we have Resolute in the Central Arctic, and then the Edmonton and Gander, which does push up into the Arctic with their reception, but we want to expand that, so I'll talk a little bit about that in a minute. The other thing is the hardware that we use currently, so the processing hardware is also very old. We've upgraded some of the processing machines, but some of the acquisition servers are still quite old, so the latency of products sometimes is slow. Our networks are okay, we're good with that, but yeah, we needed to upgrade our equipment. And then obviously the fact that we weren't accessing all of the data available, so not prepared to be able to get NOAA 20, and then obviously trying to get ready for JPSS-2 and the MEDOP second generation. So we did meet with our users. So we have a group called the Satellite Products Working Group, which brings together essentially all of satellite data users across our meteorological service. And we presented different scenarios to them on where would be best to situate antennas moving forward. There's some caveats. We need to have, we need a building to put the equipment inside. We need it to be Environment Canada land, etc. There's a few caveats, I guess, but we presented a number of different scenarios or coverage scenarios to our users, and this was the outcome of the different spots we presented. So very busy slide, but the key message here essentially is we're looking at four new locations, 2 of them the same. Edmonton or Stony Plain will be one, Gander, and then we looked at where we could improve our Arctic coverage. And so the plan right now is to install in Inuvik, which is on the west coast, west of Canada, and then Iqaluit, which is on the east. So what that does, it's hard to see from these concentric circles, but the green is essentially telling us where we're going to gain redundancy or increased coverage over what we're getting right now. The red is where we lose, and the indication from our users was that they would prefer better east-west coverage than they would over the top of the pole. So that's in our notional plan right now, is for those 4 stations to be the future polar network. So this is just a schematic, just showing what we have to do. This is my CAN slide for senior management to show them what we intend to do. As I mentioned, it's a revamp of all the supporting equipment, and the plan is to use CSPP LEO. We've had a little bit of delay in getting the project off the ground, but the intention is to create a customized version the same way we did with GEO, and for the simple reason as well of easier file to create new products in the future, to be able to merge things. Everything being under the same hood will make it a lot easier. So my colleague, Yufei Zhu, who's been here, I think he's presented at past CSPP conferences, because we're hoping he will be the architect. He wanted, I asked him if there was any messages he wanted me to send, and he just said, thanks for all the support through the GEO, and looking forward to the LEO. So my last few slides are just to talk a little bit about what's going on in Canada writ large. So I've been working public service for 20 years. I would argue that in Earth observation, we've been we're very focused on RadarSat. I think everybody knows Canada's RadarSat program. So we're up to our 3rd RadarSat mission, the RadarSat Constellation mission. And that has always really, I would argue, been driving a lot of the EO budget asks and stuff around Canada. There was a movement from senior leaders in the government to start to look at EO more holistically, and start to look at what are we doing now, what could we do, and what's a way forward. So over the last 3 years, there's been over 150 public servants working on EO, essentially looking at the full value chain, from satellite missions in the upstream and data access to the middle with the data analytics, and then looking at downstream and trying to put together, essentially we started with a diagnostic, looking at the government of Canada, where we are, what are we doing now, and then understanding what are the improvements we could make. And so we've gone forward, and in January of this year, we had a tri-ministerial release of a federal Earth observation strategy for Canada. And what that means essentially is it's giving us a policy framework in which we can leverage to go forward to our cabinet and ask for money for related projects. So essentially what we've looked at is we've looked at the full value chain, and we've developed out of this strategy has come an investment roadmap. And we're looking at a whole bunch of different investments that across that value chain that could essentially better utilize EO in the government and for Canadians. So 2 early budget approaches based on this investment plan was for our LEO, our POSE money that we got in 2021. That also included $85 million for the next generation of RadarSat reception. So it's looking at Earth, it's called Earth Observation Service Continuity. So looking at and also boosting up our RadarSat Constellation mission infrastructure. But it was the first sign by government that EO is on the spectrum more than just RadarSat. Second one was, and I saw Mike's presentation this morning. It's nice to see WildfireSat mentioned as a future mission that he'll be working with. But essentially, it's a new mission that got full funding in this past budget, $170 million to build. I think it's 3 small sats to do wildfire detection, and it's going to be in the orbit where it's going to hit the peak burning time. I guess some of the satellites are a little later for us and sometimes the fires have already started. So the way they're going to do this, I'm not an expert on this, but it's supposed to help us get an earlier warning on wildfires. So I'm sure it's in a different department that's leading that, but I'm from seeing that Mike had it in his presentation. There's obviously collaboration ongoing there. And finally, last one, I just wanted to bring this up. As part of the investment plan, there's a number of missions that we're looking at as a government to understand and see if we can put them into space. But one of them is something called the Arctic Observing Mission. So maybe some people in the room remember a satellite, maybe back in the day, called PCW. It was never launched. It was in a phase 0, polar communications weather satellite. Essentially, it never got off the ground. But following a meeting at the AMS meeting in Boston, my senior leaders met with NOAA and UMETSAT, and it kind of started this idea of an Arctic observing mission. Essentially, it's a highly elliptical orbit, looking at putting 2 satellites in space to essentially fill that observation gap in the Arctic. So we're in what we call a pre-formulation study, essentially a phase 0. We've got a 3-year project to build the business case for this mission. It's obviously extremely expensive. To put a satellite in a highly elliptical orbit is no mean feat. So we have been working very closely with our international partners at NOAA, UMETSAT. We have an international expert team that meets on a regular basis, looking at ways in which partnerships can be formed moving forward. All of this to essentially get to a business case that we can bring forward to our cabinet in the 2025 timeframe. See if we can get funding for this mission. We recognize that, as does the global community, that the Arctic has a bit of a hole with respect to observation, and this would, if it was to come to fruition, it would provide the same type of data that you're seeing with Arctica M. So if anybody's familiar with that, the Russian satellite mission, this would be the same kind of concept, except it would have extra instruments on it as well. So it would also have a GHG monitoring instrument, air quality, and space weather. So we've been working with NASA to look at the possibility of space weather payloads for that. All to say, nothing's promised, but it's exciting that Canada is showing this interest. The Canadian Space Agency has put a significant amount of money into this pre-formulation phase, and we're hoping that we can come together with a solid business case, also showing the international folks that people want this, so that we can bring it forward in 2025. Summary, very quickly, just want to say that the MSC's geostationary satellite reception network is now resilient with GRB, and it's a critical feed for our users. It's the most important data set they have. MSC's polar orbiting satellite reception network is being renewed, and this will improve our LEO data availability, which is, like I said, the most importance for our Arctic users. We've developed a federal satellite Earth observation strategy to guide EO investments. So it gives us that framework in which to come forward, and we've really worked hard to make our senior leaders, senior ministers, and I think the tri-ministerial release was a big indication that EO is on the I guess it's out there and they know about it. And I would argue that a lot of people didn't know about EO before. So this is great for us as we move forward. And finally, I just want to thank the community. The support that we were given through the GOESR program was excellent. Everything from NOAA right from the start, and then with the CSPP team and SIMS supporting us on the training and education side. I think it's just really important that we do this as a community. And again, I'm not a MET person. I came into this, I'm a sea ice person, but I'm quite amazed at the collective and how supportive agencies are with each other, and I think that's really we all have to deal with weather, and I think it's great that we have this kind of collaboration. And I'll stop there. Thank you very much.